Awesome. Well, I'm really excited to be here with all of you. There's been a lot of amazing Xamarin sessions in the theater area, and now we're actually here, full session, everything Xamarin, and building beautiful native applications for iOS, Android, all in .NET and C#. Now, if any of you are in my workshop this Sunday, you could just leave because it's going to be a repeat. You just took 8 hours of Xamarin content. So if you're here, I want to let you know a lot of people in my workshop on Sunday came up and were like, should I come? And I was like, if you like this beautiful voice, then absolutely. And you want even more Xamarin goodness, sure, but it will be a repeat. So I won't be mad if anyone from the workshop leaves, I understand. I want to make sure you get the most out of your money that you spent here at Ignite. Now, for the rest of you that came to learn about mobile app development, I'm here to really show you all of the awesome things we have built in to Visual Studio to enable you to build those beautiful native iOS and Android apps and leverage all of your existing C# and .NET knowledge. Because if you're a .NET developer, you are a mobile developer. You're a web developer, you're a desktop developer. You already know how to structure your code, your models, your controllers, your RESTful services, your Azure integration. All that is the same. It's how you build out your native user interface. And why this is important is because software is really driving the things that we do every single day. And more importantly, software is actually not just how companies move forward, it is the core of companies. There are software companies, like we used to say, like, oh, it's important that every company becomes a software company. Like, you have to move forward. Well, now software is the company, right? The Lyfts, the Ubers, the Wags of the world. Like, everything that they do revolves around software. And more so, mobile is an essential part of every single business. I can't tell you how many different companies I've talked to, from agriculture to energy to ride sharing, that I've talked to about how mobile application development has transformed their company to be a purely software-driven company. And while software drives more and more of the things that we do every day, there's a lot of challenges that us as developers have to overcome. Not only do we have to learn how to build for those things, but every single day there's more and more devices that are coming out, more emerging platforms that we can craft beautiful applications for, things that we can now speak to and touch on our wrists, or get an augmented and mixed reality experience around us. And then on top of that, we have to figure out how can we connect that up to the cloud and infuse it with AI. Now, that's where I think really Microsoft and .NET and Visual Studio all comes together to help you tackle these challenges. And you can really see the commitment from Microsoft not only to enable you to develop for these platforms, but for Microsoft themselves to ship hardware combined with software that we as developers can target. Satya not only talked about with Panos a few months ago at the Surface event our new devices, the Surface Neo and the Surface Duo, but we mentioned them again during the keynote. This will be the first time that Microsoft releases a dual-screen device, but 2 dual-screen devices. On the left-hand side is the Surface Neo, which is a dual-screen larger device running Windows 10X. And on the right-hand side, you have the Surface Duo, which is a smaller dual-screen device running Android. And as .NET developers, you can already build for all of these applications, for all of these devices, and share code between all of them. In fact, share user interface code between all of them. And that's what I'm going to show you how to do today. Not specifically for these devices. I don't have one. I would like one. But how you can actually start to build applications for Windows, Android, iOS, and a lot more. Because our goal, part of the .NET team, is to enable you to build for every single operating system and every single platform that you possibly could. .NET is what powers really awesome frameworks that will enable you to go to desktop, web, cloud, mobile, gaming. For desktop, WinForms, WPF, UWP, ASP.NET Core, .NET Core for the cloud, and Xamarin for mobile, enabling you to craft those beautiful applications, but share all of your .NET code across all of them. So let's talk about Xamarin. Xamarin is our open source app platform that's going to enable you to build those modern and performant iOS, Android, macOS, watchOS, and tvOS applications. Basically anything that you thought Microsoft would never allow you to develop for. But you can do it all in C#, F# with .NET. And And what's great about this that I'll talk about today is how you have access to all of the APIs and all of the performance that a native language developer would have access to. And there's already tons of companies all over the globe building beautiful native applications with .NET and Xamarin in all different verticals, from Alaska Airlines to UPS to the Dutch railway system to Cinemark, and of course here at Microsoft building applications with Xamarin. A few Ignites ago, I did a talk actually with one of the developers from Coca-Cola Consolidated, and he said, if Xamarin's good enough for Coca-Cola, it's probably good enough for you. And Xamarin's truly really loved by developers and trusted by enterprise because we love C#, we love .NET, and we love Visual Studio. And you can take all that goodness and bring that over to mobile development. So let's talk about that mobile development. Now, the Xamarin team inside of .NET, we've really listened to developers and say, hey, it's awesome that we want to enable you to build beautiful, modern iOS and Android apps with C#, but what else do you need? And we have a 4-tier focus on the Xamarin team. We want to make sure that you have a beautiful, productive development environment using Visual Studio, be able to share as much code across all of your .NET applications, ingest as many NuGets that you possibly could want, and of course, leverage existing .NET investments that you have at your company. We also want to make sure that you have access to native performance and native integration, so anything that you want to do on a device, you can do it. And finally, have that beautiful, expansive ecosystem, which means not even just those NuGets, but a beautiful, vibrant community that you can leverage for knowledge, for open source projects, and a lot more. Now, we develop everything inside of Visual Studio. 2019 on Windows, you have access to all of the Xamarin goodness, all of the amazing development experience that you're used to from Visual Studio, and we also have Visual Studio 2019 for Mac, giving you a .NET-centric IDE for Unity development, Xamarin development, Azure integration, and of course, ASP.NET Core and .NET Core development too. The beautiful part about Xamarin is it's included in the Community Edition. You don't got to pay us a dime. Boom, everything you want right there. Now, if you make $1 million, maybe give us 1,000. Just give us a little slice. It doesn't go to me, but it goes to somebody. And in fact, every single Community Edition feature is in the Pro version. So everything you get in there is there. And there's no real restrictions to Community. Build apps, ships app, makes money. Do it. I do it in my spare time. I freelance. I got my own LLC. Got to ship apps. That's what I love to do because that's what I've been living and breathing for the last 8 years. Now, how we build and architecture these applications looks a little bit like this. We start off with head projects. That's what I kind of like to talk about. These are our deployment targets, right? I want to build an iOS app, an Android app, or any other .NET application. And this is where any platform-specific code lives. Anything that I'm doing with my user interface, specifically like tweaks for iOS or integrating into the iOS APIs. And then we could have any other .NET app. Like you have ASP.NET apps, desktop applications, and everything's in C#, everything's in .NET. And then we build out a shared C# business logic layer. And for always, no matter what, you can share all of your business logic with any .NET application with .NET Standard. And those are your models, controllers, RESTful service calls. And in the world of Xamarin, we also have shared platform APIs and user interface that you can share across a bulk of different applications. And I'll go into that in this session. But to you, everything is in C#. Everything is 100% native with a native performance. Now, how this works is if you've ever in your life developed a Windows application, you have .NET that runs your Windows applications, or now .NET Core 3 running your Windows applications. So you have all that .NET goodness under there. Then when you want to specifically target that operating system, you download an SDK and get platform-specific APIs. So you want to do Windows networking, storage, foundation, devices, those specific APIs are there. You can think of iOS and Android development now exactly the same because you download Xamarin inside of Visual Studio and you get all that .NET goodness on the bottom. So System.io, numerics, link, XML. And then you get all the iOS and the Android-specific APIs up top. And those are all in C# with C# features like async await, lambdas, events, delegates. We take every single API that's inside of iOS and Android and create these bindings around them. So you always have access to every single API in those native platforms, but you never have to write Swift or Java or open up Xcode or anything like that. And what's great is at the end of the day, when you compile your application, we compile into native machine bytecode. On iOS, we do a full ahead-of-time compilation. Compile your iOS C# code down into IL and one more time into LLVM bytecode. And send that through the same exact LLVM compiler and optimizer that Apple themselves use to create a native ARM binary. Now, we also have ahead-of-time compilation for Android, but we leverage the awesomeness which is Android, and they have their own runtime, and we can run our .NET runtime side by side it. And we can JIT your application and JNI across, kind of like pinvoke in when we need to make native calls. But everything is compiled natively. We are not transpiling. We're not magically taking C# and putting it down into Java or Objective-C. No, we're literally compiling your app code into native machine code that runs natively on the device with a full .NET runtime, garbage collection, all that goodness, so you don't have to worry about it. Now, I want to go right into code, and what I want to start out with is just normal, standard, traditional Xamarin development. So no cross-platform stuff, no cross-platform UI, no cross-platform APIs. What does it look like to file new, and I just want to create an Android application, right? How would I structure my code? What's inside of that? And what do the tools look like? So what I'm going to do is hop over to my machine right here. I think it's on 6. Boop. There we go. And when you're inside of Visual Studio, I'm just going to go Visual Studio and say create a new project. Now, when you come into here, you're going to have all sorts of different project templates. You could go in here and you can just type in Xamarin under all projects. Oh, my goodness. Thank you so much. Wait. Control P, duplicate. There we go. That would be not a good demo. All right, cool. When you come into Visual Studio, you have all these different filters, all that stuff. And under mobile is where you're going to find Xamarin. Now, I'm going to talk about Xamarin.Forms, our native cross-platform user interface, in a little bit, but I wanted to talk about Android and iOS and the other platforms we enable you to target. Right under here, we have Android, iOS, Android Wear, watchOS, and even tvOS applications down here. Because with Xamarin, you can target all those different platforms all in C#. We only usually often talk about iOS and Android, but you can do everything. We have all sorts of other iOS-specific things like extensions. Most iOS applications are like a bunch of mini applications all in one. If you have an iOS device, anytime that you have a file picker or share something, that is an extension. If you go down and you have those stocks, and you see a little stock ticker in your little hello window, that's an extension. So we enable you to get access to all of that. And that's really important when you're building real applications. So what I did is I just did a brand new Android application. That's all I did. And this application looks a little bit something like this. It's called Demo App, which is a cool name for an app. And this application has Android things in it. So if I go into resources, I have over here, I have my Android manifest file. I have my references like Mono Android, which has all the Android goodness. I have a bunch of Android-specific support libraries, so I can add beautiful material design and backwards compatibility. This one's cool. This is Glide, which is a open source image downloading and caching library that Google recommends because Android bitmaps are a hot mess. So they say, hey, this is an amazing library. So we did the binding for that library and shipped it to NuGet. So even though that's a Java library, you can access all of it inside of C#. Now, inside of this is a native Android application. So we follow the native Android paradigms. So we have layouts and these maps, which are different Android images that are inside of here. So I can look at my launcher images. I can hover over, see all that stuff. I also have values like string translations and colors and theming. And this is just a normal Android application. Now, what's cool is if I was to come in and bop around and open one of these layout files, this is my Android XML. So it's a standard XML file. And this is the same way that a Java or Kotlin developer would develop their user interface. So over here, I have my Android designer. So it's spinning up over here. And I have my Android XML on the right-hand side. So I'll give it a few seconds. It's the first time I did it, so there we go. So I have a little login screen. Kind of wanted to kind of walk through the basics of what this would look like. So I have a login screen, and I have full toolbox over here, so all the different things that are available. I have a property grid, all the things that you'd expect, drag and drop, all that goodness. I can see what this looks like with different themes that are available, different versions of Android, different device sizes, all that goodness. Now, what's nice here is that we built our XML editor specific for Android. So that means we light up a bunch of Android-specific features. So over here, we have some colors that are in here. When I hover over it, I not only get an inline, but I get to see the actual hex value of it. This is coming from an attribute, which references a color, which has a hex value. This is an Android-specific color, which is really cool. But we also do some other things. So inside of this button, it says login. But it's not translated. We would use a built-in string. So if I say @string over here, let me do that string and zoom in over here. Let me spell it right, string. We get all the Android-specific resources, and I have a few in here, such as login. And what's really nice is that this not only gives me the IntelliSense, but the actual translation here, right? So I can actually say, oh, here's login for login button, and now it's still login, which is very nice. So I kind of get access to all of this. And we also built in really smart commenting and uncommenting. So here I have this layout height. And if I comment it comments out the entire item here. If I comment it back in back in and out. Very nice. So we have all these niceties inside of here to help build user interface code. But I'm going to build more than just a login application. I want to build a full application. So what we're going to build really quick is a application to help me visualize some monkeys. You could have noticed by the bunch of monkeys over here, and if you saw me at the Visual Studio for Mac booth, I was just building a monkey application, because that's all I do in life. They pay me to build apps that showcase beautiful monkeys around the world. So what I've decided to do here is go off to the internet, grab a bunch of monkey data, and put it into my Android app. So over here, I have another library. So this is just a .NET Standard library. And this is going to use like newtonsoft.json, and I have a bunch of JSON that's coming down from my web server. And this is great because this library, I'm sharing it with my Android app. But if I decide that I need a Windows app or an ASP.NET application or an iOS app, I can share all this code there. So the first thing I have is my monkey. So I filled this out. It's just a bunch of string properties like name, location, details, image, population, and a latitude and longitude. And then what I want to do is fill in this view model over here. So I want to show you how that it's just normal C#.NET code. We've built models forever, and now what I need to do is go off to the internet and pull down some monkey data. So where does that monkey data live? Well, it lives on my personal website, obviously, montemagno.com/monkeys.json. And then, of course, I'm not going to host it. I'll let GitHub pay for it. So I'll just put a little 301 redirect in there. But yeah, this is all the monkey data. So it's a big JSON feed of monkey data, of real monkeys and monkeys that travel around with me, like Sebastian. He's ready to go home, and a few other little stuffed monkeys in there. And that's our data source. And this could be your ASP.NET Core, web API, for instance. But here I'm just having a little data. So here's what we're going to do. We're going to do a little try, a little catch, little exception EX. And if anything goes wrong here, let's just go ahead and not throw and crash our app. Let's do just a debug, write line. Right? Just put that out right there, ex.message. Boom. IntelliCode's working. It's telling me message is good. So now I have one way of logging, debug.writeLine, console.writeLine. We abstract all that for you, so it goes out to the native iOS or Android logger. But let's go off to the internet and get some stuff. So I'm going to new up a new HTTP client. New HTTP client, right? Just little HTTP client. I'll say var JSON, and I'll say await. So normal async await, all inside of an Android app. I'll say client dot get string async. And then I'll go to https montemagno.com. And then let's put this on a new line so I can read it. Boop. /monkeys.json. Boom. All right. Now we got our monkeys. Now over in our monkey class, I wrote a little helper method over here. So this is monkey.from JSON. And this will automatically deserialize an array of monkeys for me. And it uses some default JSON converter settings, which are nice. So I'm going to go over here. I'm going to say var monkeys equals monkey.from JSON. JSON. Boom. Now I have my monkeys. Literally just 3 lines of code. And I'm just going to go ahead and say for each var m in monkeys, we're just going to add it to my monkey observable collection here. So monkeys.add and then m. Cool. It's not too hard, right? Just it's code that you've written a billion times, right? Hopefully. If not, if it's new, this is how you do it, which is cool. So now you're like, okay, James, like I know how to make RESTful service calls. How do I build an Android application? Well, cool. So Android applications, they all have something called a main activity. This is going to be the starting point for my app. So the starting point for my application comes in, and I give it an app name, and I tell it it's a main launcher. And when you compile your app, we automatically figure out everything that you need to tell it that this is the starting point for my app. You can see Visual Studio is all mad at me because I have an editor config, all the stuff that I'd be used to. Now inside of here, I do a few things. I get my toolbar so I can set like what type of application it is. And Android applications are a bunch of components, really. They're called fragments. They're bits of a screen. So my application has a monkey list fragment. And this monkey list fragment is not an activity, but it's a fragment. And then this is where I bring in my code. This fragment is going to have a list that I can display monkeys inside of. And I'm going to do that via this monkey view model right here. And this is going to open up the fragment monkeys layout to display. So let's go ahead and open that and take a look at what that looks like. So fragment monkeys, there we go. So now we have our designer. You said it's a lot faster because it already spun it up. And this is 2 things in our UI. We have a button. It's a beautiful UI design. But I have a linear layout that I'm stacking these vertically. And I have a button that says refresh. And I've given it this identifier, like a name, called button refresh. Then I have a recycler view. And this is a super hyper optimized list view for all intents and purposes here. Now what we see is that I have like some sort of design here. We actually extend the designer with Android design tools. So in here we have these tools. This I'm telling it there's an item, like my cell is inside of this other file called monkey item, and there's an item count of 1. But I could come in and say, oh, let me show me 3 of them. And this will go off, and then it should render 3 items. But they don't look so good, so let's actually go into that monkey item. I'm going to hold down Control on my, see how that lights up blue, like a hyperlink? I tap on it, and boom, Visual Studio navigates to that page. Now it's blank, which stinks, but I have another linear layout. I have an image view. I have some text views here and another text view. So what's nice is that we also leverage design time data for individual controls, not just lists. So I can come in and say Tools, Source, and instead of putting like a dummy image in, I can tell the designer to use some pre-baked stuff. So here we have avatars. There we go, and there's an avatar. If I come over here, I can say Tools, Text, and I'll say do full names. So now I see that over there, and let's do city. So we'll do Tools, Text. And you see every time I type it updates, which is kind of funny. I'll do cities. So now we get like a better representation of what my cells would look like inside of here just by simply adding a little bit of design time data. So you get that really nice loop back. Now if I go back over here and if I change this hopefully to 1, it updates there in real time. So I can actually see that view from this view, which is very, very nice. And if I put in here, like 3, then I get 3 different ones, which is pretty cool. So now I have my UI. It's looking really, really good. Now let's go ahead and whenever I click that button, let's go ahead and call that, that view model that I wrote earlier. So inside of here, I find my refresh view via that ID. And I'm just going to come in and say refresh button dot clicked, right? A little click event plus equals. I'll do some sender args Just like put like a little lambda in there. So boom, click event, done. Right? There's no overriding, there's no on click, there's no callbacks, it's just an event. So now once I have this, I can say refresh button dot. I get every single property, everything I want. So let's disable it maybe. And then when I'm done, refresh button dot enabled, boop, equals true. And now we're going to call into our view model. So I'll say await, and I probably need to pair this with a little async. So I'm going to go off on the background thread, and I don't want my UI to be all locked up. But I'll say view model that I defined earlier, dot get monkeys. Cool. So this is going to go get the monkeys and fill that observable collection. Now, at the same time I have that list, to be able to display all my monkeys, I have this adapter. And this adapter knows about that individual cell that I just created. So what I do in this monkey adapter, if I go into it, is what I do is I pass it some data, and I say whenever my monkey collection changes, update the UI for me. And then down here, I tell it to inflate that monkey item, and then I bind. So every single time I scroll, it will update and say, oh, grab the current monkey at that position, and then bind it to the UI with the name, the location, and then I'm going to use glide to display those. So let's just hit debug, and inside of Visual Studio, it displays any Android device or any Android emulator that I have on my machine. So I have this Android emulator that I've deployed down here. This is running on top of Hyper-V on my machine. So if you're doing Docker development, you could do that side by side. And let's also come into our shared code, and let's add some breakpoints in here. So let's add some breakpoints. Now this is compiling all my changes, right? So it just did a full compilation of my Android application, and boom, it's deploying it right here onto my emulator. Starting a full debug session. And there's my UI, everything's ready to go. I'm going to hit refresh. It goes off, I hit a breakpoint in Visual Studio. I go off to the internet. I hopefully grab some JSON data. Boom, there it is. Awesome, rad. And then I can go ahead and deserialize those puppies, actually those monkeys, and then I get some monkeys. Right, here we go. I'm just using Visual Studio. I'm just developing, right? I go off and I get some monkeys. Cool, awesome, right? Now, a lot of that you already knew. You know how to add click handlers, you know how to do HTTP requests, you know how to do JSON. It's just that UI layer that you need to know about. But then you're saying, wow, James, like that was actually not too difficult at all. But like, how would I like go about leveraging all that cool native stuff that you talk about, right? Because you're like, hey, James, you know, like you said that I could build beautiful applications, take advantage of everything. You're just building some UI. And you're right. You know, one of the things that I love about these action-packed and really powerful devices we have are all these great APIs that we have in our pocket available to us. Like permissions, machine learning, notifications, messages, music APIs, face unlock, just even simple things like battery access, camera access, connectivity access, right? Now, what's really cool is that Xamarin gives you all of these APIs all in C#. So if I need to have access to permissions, I have access to all of that in iOS and Android and Windows and any other platform I want. Same with connectivity. But the team, we thought, well, you know, it's really great that you have access to that raw API, but man, wouldn't it be way more productive if you didn't have to go write the code for iOS, Android, and Windows over and over and over again? I mean, it's great that it exists, but what if you could write it once? And what if we just took care of all that gobbledygook shenanigans for you? So we did it. And we created a library called Xamarin Essentials. It ships with every single template inside of Visual Studio. It offers over 60 native features from a single cross-platform API. So things like secure settings, clipboard, phone dialer, device information, connectivity, compass, text-to-speech, sensor information, a whole bunch more. We've added tons more on top of this. It works across iOS, Android, Windows, tvOS, watchOS, and even Samsung Tizen devices, which means that you can run Xamarin applications on your refrigerator. That's totally a thing that Samsung, we partner really close with them, enable you to do. We want to run .NET everywhere, right? Now, what's cool about this is you're saying, wow, James, that's a lot of APIs. It's going to like bloat my application. I'm all scared. Don't be. We've optimized it. We have an advanced linker and compiler. So when you compile your application, if you only use the gyroscope, that's the only bit of code that will be added into your application. We finely tune it, and we strip away and we link away any of the APIs that you don't use. We apply the same technology not only to libraries like Xamarin Essentials, but also to .NET itself that's running in your app. Because .NET's big, so our .NET runtime and .NET library is very small, just a few megabytes, which is very impressive, actually. And that's what we do with Xamarin Essentials. We go ahead and trim it down. So now your application starts to look a little bit like this. You have your shared C# business logic, right? That's that model, view model I just showed you. But you just have to, put a little Xamarin Essentials in there. Let me show you what that looks like. So let's say I want to integrate connectivity into this application. So what I would do is I would come in and I would right-click and say Manage NuGet Packages. You would search for Xamarin Essentials, which I've already installed right here, and you'd install it into your .NET Standard library and your iOS, Android, and Windows apps. The .NET Standard version is like your interface that you're coding off of, and then the platform implementation is there. And then if you're like, oh, I'm interested, like how do I get started? Well, you go to docs.microsoft.com, click on Xamarin, and then somewhere on this page, you have Xamarin.Forms, Android, iOS, and then down here we got Xamarin Essentials. Beautiful documentation on getting started and every single feature API, geolocation, phone dialer, secure settings, all that stuff. And here's connectivity. You tap on it, and we're going to show you, hey, are there any specific permissions that you need for any of the platforms to get access to this API? And for this, we do. So we say, hey, add this little bit of code in your Android app. For iOS, Windows, you're good. Down here, we're going to show you how to get it. You want to get access to the current network access state? One line of code. Do you want to come in and figure out how you're connected to the internet? Cool, we got that too. Do you want to register for connectivity changes? Add an event, right? What's really nice is that we also have videos, API documentation, and source code links. Everything's open source. Here's API docs. Here's the source code. You can come in and see how we built it, right? It's all available. We wrote hundreds of lines of code. We wrote thousands of lines of code for you. Not just us, but the community. We collaborate to see what APIs you need. And you can submit your own PR, add a bunch of cool stuff. So let's do this. I've gone in and I've added that line of code, that access network state. Now, this isn't going to be a pop-up, but it's just something on Android that it built in to access that API. So now what I can do is I can come into my view model over here. And before I go and reach the internet, let's do this. I can say if, let's zoom in, Xamarin.Essentials. There it is. And I have every single API available to me. All of them. There's connectivity. Bam. Now, I've already brought in the using namespace, so I'll go ahead and get rid of that. And I will say .network access. And we'll say if it doesn't equal, so if I don't have internet, right? Let me just go ahead and return out of there and do debug.writeLine. Telecode pops in, and I'll say no internet, sad face. Cool. So now, one line of code, tap on that, hit debug, right? And now Visual Studio is kicking in. It's going to rebuild my application with that line of code. Now, I've already gone ahead and built it once, so it's going to go ahead and deploy, hopefully, a lot faster. There we go. Because it only needs to do a conditional compilation there. So now this will be good. I'm going to go ahead and tap on refresh. Boom. If I hover over this, internet, rad, go off. Let's go ahead and remove these breakpoints. Boop, boop, boop. Hit continue. And I get monkeys. Now let's say I put this puppy into airplane mode, right? I'm about to go out and get on an airplane in about 3 hours. I don't have internet access, but I still want to see monkeys. I hit refresh here. Now when I hover over this, we can zoom in and see I have none. Now at this point, you'd probably have some caching layer, maybe SQLite, maybe some file cache, maybe you're using App Center data, and then you would display your cache data, maybe not just do a debug write line. That's not a best practice. Don't do that. But yeah, now we have no internet, right? And if I come back in, put back on internet, boop, tap on that, have internet again, right? It's awesome. Come back in, I have more monkeys, right? More monkeys over and over and over again. And it's just that easy to start using these cross-platform native APIs. Since Xamarin is built on top of native, you have access to all that, but we do one better and give you a cross-platform version. Now, so far, I've just been building an Android application. And you might be saying, James, that's rad because I just need to build an Android application. And my designer came to me and said, I need super crazy, ridiculous, super customized user interface. So with Xamarin Traditional here, you have access to every single thing that a traditional native language developer would have. But then you're saying, James, I would like to share more code, please, and I would like to build beautiful applications, but share all my UI. We got you covered too. Because what the team did is we said, hey, wouldn't it be great if we could share more code and more UI? We built Xamarin.Forms. Xamarin.Forms is a cross-platform open source mobile UI framework that enables you to build native iOS, Android, and Windows apps from a single shared code base. Now, how this works is really unique because we always show and render the native user interface, which is really awesome. But we've abstracted all of the common controls, common layouts, common paradigms into a single cross-platform API. Now, what's nice is that you can blend these two worlds together, okay? You can start with a Xamarin Traditional app or a Xamarin.Forms app, and you can blend screens together. So if you want to inject a little bit of cross-platform UI in your Android application, you can do that, or go back and forth. But here's how it works. iOS and Android, they have controls. Over here, we have a UI activity indicator, which gives us the iOS look and feel, and a progress bar on Android. When you develop it with traditional Xamarin, this is what you would use. But with Xamarin.Forms, you have a single control with common properties, common events, and we call it an activity indicator. For other controls, like UI slider and seek bars, we do the same thing. We just call it a slider. We go back and forth. Sometimes we use the iOS-specific mobilize or the Android one or the Windows one. We create commonalities between this for a mobile-friendly API. And we do this for 50, 60, 70 different of the most popular built-in controls in iOS, Android, and Windows. But we have an amazing ecosystem of control vendors like Telerik, Syncfusion, DevExpress that have built Xamarin and Xamarin.Forms controls, but also an amazing community that builds all sorts of lovely things too. And even though it's a cross-platform API, you still, as a developer, have access to the native control under the hood. So if you need to tweak it and tune it because your designer told you needed it to look a little bit different or something crazy, something that isn't exposed cross-platform, you still have access to it. You always have that escape hatch, which I think is very powerful. So now your applications look a little bit like this. You got always shared C# business logic. You have Xamarin Essentials, as much or little as you want, and Xamarin.Forms, as much or little as you want. Like I said, Xamarin.Forms has over now 60 pages, layouts, and controls that you can build from C# directly. If you just want to say a new button and add it, and boom, you got good to go. You have a new button. Or from XAML. So if you're coming from a WPF, UWP background, XAML user interface there, which means you have a full two-way data binding system. When you type something into an entry, it automatically updates your code behind and vice versa. But the team has also abstracted navigation cross-platform, animation APIs, a visual state manager, and a lot more. So here's what we're going to do. I'm going to go back over here to my machine. And I'm going to go ahead and open up another project. And this application is another monkey application, because what's better than one monkey application? Two monkey applications, that is correct. And this one is going to be a fully cross-platform application with 100% code reuse between iOS and Android. Now, I could also add a UWP project too, if I wanted to, or a Tizen project. You can build all of this for your Samsung devices too that are running Tizen, like watches and fridges and all that stuff. So the difference here is I have that Android app, but I also have an iOS app, and we'll talk about that in a little bit. Now over on Android, I have all those packages. I have Glide, I have Newtonsoft.json, I have all this Android stuff, but I also have Xamarin.Forms installed. And that's where all the Xamarin.Forms goodness comes from. Now if we take a look up top at my shared .NET Standard library, which is right here, boom, I also have Xamarin.Forms installed. And of course Xamarin Essentials, it's essential. Now the difference in this application is that I not only have my model, which is that same exact model we saw earlier. I also have my view model, which has very, very similar code here. So here's that get monkeys async. The only difference is that I have a few more lines of code in here to handle exceptions, and this is busy property. And this is busy is going to enable me to do like little spinners on the screen. Now over here, what's really nice is that I need to have a way to tell my UI to invoke that method. So instead of just calling it directly, I could say click, new up this thing, and debug it. I'm going to create this command, so get monkeys command. And what that's going to do is it kind of is a bridge between my UI and my view model. And this command is going to say, when somebody clicks on that button, call this get monkeys async, and then just go off and do stuff. So core to any Xamarin.Forms application is an app. And inside this app over here, we have some styles and colors that are shared between all my apps. I have some code behind here where I'm creating a brand new page with a navigation page on top, so a little header. And then we even abstract out the app state. Now it's important that we still have an Android and iOS application because that's where I would write any platform-specific code that I need, and is also where I initialize my application. So I need to tell Android, go start my app from Xamarin.Forms. But I still have an activity, I still have all that goodness. So what I'm going to do over here is just hit debug. And I'm going to open up my main page.xaml. So this is full XAML user interface. And the only thing that I've done so far is I've added a grid. So I have a grid with 2 rows, a big row up top, a small row on the bottom, and 2 columns that are 50-50. And then I can start to add user interface control over here. So again, I'm just going to start a debug session over on my machine. Again, this will take a few more seconds because I am compiling it for the first time. So we'll give it a few seconds here. There we go. Spinning up and copying over all the files. And there we go, zip aligning, doing some stuff, copying files, and boom, we're debugging. Now, one of the really cool parts about Xamarin.Forms is that we own the UI, which means we can build advanced tooling into Xamarin.Forms. So what we see down here is that hot reload is connected and initialized. We've built in XAML hot reload into Xamarin.Forms, which means I can write my code, hit save, and it updates automatically. So let's come over here and let's take a look at this. Let's go ahead and push this down. And what I'm going to do is come in and I'm going to add a button. And what's also nice is you'll notice that as I type, I get IntelliCode in here, which is very nice. So I'll say get monkeys. There we go. And I'll just close it off, and I'm going to hit Control S. Now what that's going to do is go communicate to my emulator, and boom, I get a button. That's a big button in there. So let's put it down on grid.row1. Now it's down there. Now I can give it a little bit of margin, so it's a little bit further away. And on top of that, I was smart ahead of time and created this beautiful button outline style. So it has a bunch of reusable stuff in here. So let's go ahead and set a style on here. So style, and then static resource, and then boom, our IntelliSense shows it to us. Awesome. Cool. Get a beautiful button that says get monkeys. But we're going to need to put in a visual indicator that I'm doing something. So let's go in and do an activity indicator. And I'm going to say is visible. We'll say true. Is running, true. And then I'll say grid.row span 2, and then grid.column span 2. And then let's hit save and see what it looks like. And boom, it's a huge spinner. Oh my goodness, that's too big. Let's put that in the center and then do a vertical here of center. And now we should get a nice small spinner. That's good. But I'm going to kind of leverage this and bind it to that isBusy property. So only show it and only run it when I'm actually doing stuff. So let's bind up this click event, if you will, on this button to that command. So I'll say binding to command of get monkeys command, and boom. Now, whenever I click that button, it's going to go off to the internet, pull it down, and then almost display my monkeys. Because what I need to do is put a list view in here. So I'm going to say item source, and I'll say binding to monkeys. Do this. Let's go ahead and actually open and close it, hit save, and now I get some monkeys. So it keeps my state, everything that I need. Let's span that 2 rows, so grid or 2 columns, hit save, so now it's full. Now what we can do in here is give it an item template, like what is each one of those cells going to look like. Now I could spend some time crafting this, but I'm out of time literally, so I'm going to copy and paste some code. Boop, over here. And I'm going to give this a beautiful cell and hit save. Almost. We need to do one more thing. We need to tell it how big each row is. So we'll just say, hey, Xamarin.Forms, calculate it for me automatically. And boom, with ever having to stop, debug, or do anything, now I have a beautiful monkey application with frames and cards. Xamarin.Forms automatically downloads the images for me. Over here, we can see I have an image that has a data binding to image, a label to name and location. And now I have this beautiful application here, right? That I can scroll through, see all my monkeys in real time. Now, if I want to get this on iOS, I'm going to set iOS as my startup. There we go. Now, I'm also connected to my Mac, which is up here, over a secure SSH. That's where Xcode, iOS simulators, all the iOS build tools live. And right now, as of today, what we have available is a way for you to simply connect to your Mac. We'll show you all of your iOS simulators or devices plugged into your Mac, and you can just hit debug. That will compile your code and then finalize app packaging on your Mac, because iOS applications need to be compiled up on a Mac. Now, there's been a few sessions here at Ignite that we've talked about Hot Restart, which is a new technology that we're coming out with that will enable you to just plug your iPhone into your Windows machine and will sort of interpret your application. But that's in a private preview today, and I want to show you what you can go do today. Now, what I've done here is I've selected a simulator, and I hit debug. And then a simulator shows up on my screen. And that is because we created a remoted iOS simulator for Windows. So what Visual Studio did is it actually started a simulator hidden on my Mac, and we're basically screen mirroring it to your PC, which is very, very cool. Which means now, when I come over here, I have my UI. I can say get monkeys. I get that little spinner there. And now I get all those monkeys on here, right? And all of that hot reload, all that stuff works on iOS simulators, Android emulators, devices, anything like that. But I get the same exact look and feel. I'm reusing all of my UI logic. And of course, I can start now accessing Xamarin Essentials, tweaking my UI, anything that I want. So now I have beautiful monkeys absolutely everywhere. All right, let's wrap it up here and get you out of here. So I just took a few minutes to build some Android applications and some beautiful monkey applications with Xamarin.Forms, but you can build all sorts of good stuff with Xamarin.Forms. We did a community challenge telling developers, hey, take a few hours, build some stuff. So here's Coinbase. That's the original. They rebuilt it in 2 hours with Xamarin.Forms. Someone else, one of our developers, Ryan Davis, flies Qantas all the time. This is what the app looks like. Rebuilt it in 2 hours with Xamarin.Forms. Someone rebuilt Netflix with Xamarin.Forms. So when people say, can you build beautiful things with Xamarin.Forms? Yeah, we've been doing it for years. You just have to be able to just, create that UI. But we give you all of the APIs, all of the controls that you need. Another one of our developers, Steven, took a dribble design, something that hasn't even been created. On his flight home, he just recreated it in Xamarin.Forms. Now, the last part I want to talk about here is not how you can not only build and craft beautiful applications, but how you can integrate with everything that you already love. There's tons of beautiful NuGet packages, libraries that you can consume. Things that we provide at Microsoft, like Azure AD, Cognitive Services, all of the Azure SDKs, tons of third-party libraries like Lottie, Zebra Crossing for barcode scanning, and great ecosystems such as Syncfusion, Instabook, Raygun, Telerik, things that you may have heard of before. Tons of great frameworks that have been built with and on top of Xamarin to help you be more productive, like Prism or Reactive UI. And of course, being able to integrate it into your existing continuous integration and delivery pipeline. It's a mobile application. Just because it's from Microsoft doesn't mean you have to only use Microsoft things. We understand that you may have other clouds, and that's OK. I think our stuff's pretty great, though, so you should probably use it. Including those clouds, like Azure or any other backend, we have those APIs available. Yeah, I like our Azure stuff pretty good. So you should give that a try. But all these SDKs are available, so you can get access to all of that today. And that's really how we're enabling you to build for any platform. Whether you want to build beautiful native applications for iOS and Android with Xamarin, or leverage that shared code across other platforms, it's all available to you. You can get started by going to Xamarin.com or just install Visual Studio. All of my applications are available on GitHub. And with that, thank you so much, and have a great Ignite.